In this example, I want to point out a place where the average value of a function is used, and this place is in household current. Okay, in household current, we usually think of household current as being 120 volts and 60 cycles. All right, now what does that mean? Well, when you plug into an ordinary receptacle, there are two contacts, all right? One is neutral and one is hot. And the neutral is just connected, basically, sometimes even just connected to a ground, and it stays with 0 voltage, 0 potential. All right, the hot wire, all right, it has a potential that alternates. It alternates, and it alternates up to a peak voltage and then back down to the opposite of that peak voltage, negative, and then back to neutral. Starting at neutral, up to peak voltage, back to neutral, the 0 voltage down to negative peak voltage, excuse me, and back to neutral again. And the thing is, this cycle takes 1/60th of a second. That's why we say it's 60 cycles per second, or sometimes they'll say 60 hertz. And so what we want to do is we would like to calculate what this peak voltage is. The 120 is what's known as an RMS. And what that stands for is a root mean square. Now, mean is just average. That's just another way to talk about the mean. A mean is what we mean by the word mean is average. And we'll talk about why with the root and the square in just a second. So if we look at this, all right, if we look, well, let's take a look, I guess, here. If we look at this, if we average this over one cycle, well, we'd integrate it over one cycle, and the integral would be 0 because we'd think about this being at 0 volts, and so there'd be some area up above, but then the same amount of area down below, and so we would just get an average of 0. So what we do, what happens is instead of just looking at the voltage coming out, we actually square the voltage, and when we square the voltage, all right, we get a curve like this, or negative. So when we calculate an integral, all right, we're not going to get area below the 0 that will subtract, that will subtract off, as we saw before. All right. Now, in order for this to happen, remember this is at 1/60. We know t goes from 0 to 1/60, 1/60th of a second, because it goes through its cycle 60 times each second. We'd like to see what happens. Excuse me. What function of t will go from 0 to 2 pi, so we can put that into sign. Well, we'll do the same thing before. We'll make a 1 here, so I'll multiply everybody by 60. 60 times 0 is 60, and then I'll have 60t, and that'll be less than 60 times 1/60. So as t goes from 0 to 1/60th, all right, this expression goes, 60t goes from 0 to 1. And then remember, we want it to go from 0 to 2 pi because that's the period for sine. So if I multiply by 2 pi, I'll get 60 times 2 pi times t is equal to 1 times 2 pi. So as t goes from 0 to 1/60, this will go from this expression will go from 0 to 2 pi. Of course, we can write that another way. That would be 120 pi t will go from 0 to 2 pi. And just think of it for a second. If this, when t is equal to 0, this expression is 0. When t is equal to 1 over 60, 60 will cancel with 120, leaving 2 pi. And so we'll finish a period of sine. And I'm just going to call the amplitude right now 1, okay? And so we looked at sine squared. Now what we're going to do is we're going to calculate the average value over one cycle of sine. I guess we could have, when we square it, we could have calculated over a half a cycle. And so notice what this would be. All right, notice we squared this, so we take the peak voltage, all right, which we've multiplied to get the height here. The peak voltage times the sine of 120 pi t squared. That makes sure that we don't have parts below the t-axis, okay? And then integrate that from 0 to 1/60th over one cycle, and then divide it by the length of that cycle. Well, the length of this cycle is 1/60th, and so we have 1 divided by 1/60th. And of course I can take, when I square this, I'll have v squared, v peak squared times sine squared. And so I can take the v squared out of here, and 1 divided by 1/60th is 60. So I have a 60v squared. I can take the v squared out of the radical, the square root, because I've squared this. All right, that's where the root comes in. The root means square, all right, root, and then we're taking the mean value of the square, okay? And anyway, so I'll have this v peak, all right, times the square root of 60 times the integral from 0 to 1 over 60th of sine of 120 pi t squared. Now, you learn to integrate this expression, sine squared, in Calc 2, but we'll just see how that goes. Sine squared, okay, sine squared of, using the double angle formula for cosine, actually, sine squared of 120 pi t is the same thing as 1/2 minus 1/2 the cosine squared of 240 pi t. And you could, I mean, the thing is, what we do is use the double angle formula for cosine. It's cosine squared theta minus sine squared theta. And so the cosine of 2 theta is, cosine squared is 1 minus sine squared, minus another sine squared of theta, and then we would get, if we solve this for sine squared, we get sine squared of theta is equal to 1/2 plus 1/2 cosine of 2 theta. And now just let the theta be 120 pi t, and we get 1/2 plus 1/2 cosine of 120 pi t. Did I do? No, I think that this is supposed to be a minus sign. Okay, at least okay. And so when we integrate that, when we integrate this, I get t over 2. Integrating this, integrating cosine of 240t using u substitution. U is 240 pi t. I get sine of 240 pi t over 240. All right, and that gets evaluated from 0 to 1/60th. And so if I evaluate 1 over 60, I get 1 over 120. And then a half, well, 2 times 240 is 480. Sine of 4 pi. Okay, again, replacing the t with 1 over 60. Sine of 4 pi is 0. Then when I replace t with 0, I get 0 over 2 minus 1/2 sine of 0 over 240 pi. So I get that sine of 0 is 0. So this just becomes, this is 0, this is 0. Of course, we have 0 here. This just becomes 60 times 1 over 20, which is 1/2. So the voltage, the 120 volts, which is what the root mean squared is the peak voltage times the square root of 1/2. So if I multiply both sides by the square root of 2, I'll get the peak voltage. And if you calculate this, you get 169.7 volts. And this is a place where, and so that would be the peak voltage of your outlets in your home. The 120 volts that are talked about are basically the root mean squared. And if you have a peak voltage of 169.7, we'll have a root mean squared of 120 volts. That's a place where the average value of a function is used.